Yes. Alrighty. We're back. We have some 3D printed parts. And we have a Hemera Bowden setup. Just to recap, I went through putting together the frame and then installing the Duet 3 boards and the power supply, just a couple of things, like the main physical large objects. Now we're going to start getting into smaller things like extruders, hot ends, tool assemblies, and then also we're going to look into actually wiring this bad boy up. For this video, I'm pretty sure we're only going to stick with installing the Bowden setup, where we'll do one Hemera Bowden and then we'll just do one Hemera tool. From that, we'll install it into the printer itself. So for this, I used a Polymaker Polylite PLA, just a nice violet. Let's get into assembling. Again, I'm only going to do one of these for this video, and the plan is to actually only start with the Hemera tool itself and not really the Bowden setup. I want to do the Bowden though, just to do some tests and comparison between the two for personal interest sake. So that's where I'm going to start. This is detension. We'll get into that whenever that time comes. We're looking for M3 8mm screws with socket head caps, 6mm. So here's some 8mm ones, because this is the tool build. It should be in the supplies for the tool itself. I've gotten all excited. I organized things, kinda, sorta. And now I'm not even going to use it. These do look like 6mm. I'll go ahead and try these, and I'm not worried about them being too short at this point. I'm more worried about them being too long, because those nuts you can't over install. They will run into the motor block on the back side, which is all fine and dandy until you over tighten. And so that nut is right on the inside, and once that screw comes through, it'll hit the back wall, which will cause either the bolt to go into the aluminum part or to pull this nut outwards, which it's more likely to actually pull the nut outwards. And all you have is just like a real tiny lip here around the nut, and so it will just break that off and ruin this casting, which, I mean, you can get a replacement, but why break something if you don't need to? Let's get to it. So it looks like whenever we place this motor, this side will be on the outside of our electronics panel, or boards, I guess, where the rest of the electronics are. And then this side will be on the inside of the build area. The only thing that I'm concerned about is it will put part of the motor kind of close to the interior environment, but it will keep this entire hot end on the inside, and then this lever does protrude out a little bit, so that does have to be fully inside. It can't be rubbing that wall. I mean, it could, but it's going to be a hassle if it does. We'll just snug it for now. That seems pretty solid, and I'll leave these just a little bit loose here or there. I'll just move them all the way to the inside. And the hard thing is you can't really tell if these screws are bottoming out or not unless you look down, like right here. So I'll get a flashlight and look myself just to confirm. I don't think I'll be able to show you, but that is a good place to check, just to make sure that we're not going to push these screws too far. Right now it looks clear, so I'll just keep continuing, and if I see them poking through and starting to hit the wall, I will pull it out and stop. Make sure it's secure. We don't want this wobbling too much. Grab our remainder screws. There we have it. I mean, isn't that gorgeous? I think the other color that I could have chosen, if it had been in stock to get it as quickly, would have been something like this teal blue. Would have gone really well with the aluminum, the bare aluminum, and the black combination. But I really like this light violet. I think it's gorgeous. Okay, well, it says to tension it now, so we'll just go ahead and tension it now. And I'll see if I can get this a nice little angle for you to possibly see here. I'm just going to pull this in, and that white plate, as we talked about, just go until that's flush. And it's just nice and easy like that. Just run the thumb across it. It's good enough. Very nice metric for how much tension to put on it. And there's still room to move too. Like, you can pull this until it's a good bit out of this block too if you really need that extra tension. And it just goes back as soon as you release the tension. Very solid, very nice. The last part is installing this Bowden Camera. So what I'm going to do is I'm going to install this side up, which this will feed to the hot end itself, and then this side is your intake side, and so that will be facing down. This will be facing up. This will pull off a spool. I'll probably try to run a Bowden tool all the way to the spool, just for consistency's sake, and like knowing that I'm going to have a clean pad. And then of course there's a Bowden going to the tool itself, and the tool is going to sit up and on the inside. So if the extruder is sitting, let's say, on this side of this line, the tool will sit just above this line or a little off to the side. That way that Bowden tool does have a nice little bunny ear, it can make there won't be any interference. And it looks like I'm using pan head screws, so I'm going to go ahead and put all these back and find some pan head screws. We're going to be using the motion assembly components, so that'll be coming from here, our pan head, and it looks like it's these short guys, possibly. And it looks like there's not enough in here, so I'll have to find some. I'm just going to use these. They look like 10mm and 5 and 6, something like that. Screws. They will have enough length. I found washers that happen to fit, so I'm just going to use those. And the other thing is they actually do fit where the hole is undersized, so that it's going to self-tap and make threads, which will give us the security that we need. That feels pretty nice. By the looks of it, we're not going to actually have room for the washer. Yeah, that washer isn't going to fit. So I'm just going to try it without the washer, and we can work out washer details later. Now that we have a solution, let's go implement. We're going to have our Bowden side coming up to the top of the machine. And then we're going to have our intake side coming up from the bottom of the machine. Now it did give us like good 6-inch piece of Bowden tube to use, but I'm not going to worry about that right now because I want to actually have a nice long run to the spool of filament. Now I'm aiming for snug, not tight. As always, never tighten until the very end. Beautiful, it still wiggles, but it holds it nice. Now, since you're on this side, I will include a washer on this one just to see if we can't make it work. Especially since that's slotted and it's not actually a hole itself. I want to make sure there's as much surface area coming in contact with that acrylic as possible, as to prevent cracking and maximize stability. It appears the washer actually works, so I'm going to use washers for the remainders, and I recommend you doing the same. But based on part count, I will be buying parts for this. I'm super thrilled with the actual engineering that went into this build. A lot of stuff is way overdone, and that means that by getting this assembly, you find this is engineered for essentially an unlimited lifetime, because it's their one that they came up with. Make rock solid so they can just throw anything at it. So I'm happy with that kind of setup, and I'm okay with going through all the extra hassle because of that. But this is fully installed. I used the washers. I'm going to run out of hardware. Doesn't matter, we will get through this and we will have a finished product of 2 working setups, 2 different tools, and for that I'm really excited. And so let's just get on and assemble the Hemera tool. No, I take it back. We're going to finish this tool first with the V6 hot end, so that'll be a couple parts, and then we'll go on to the Hemera tool setup. So real quick, I pulled these parts off of the same source. I just ran it twice. This one, the printer assumed that flat was right here out on the tip, and so the rest of this was an overhang and a very shallow angle. I'm very surprised that I was able to hold it together, but I went ahead and repainted it anyways because I wanted a nice surface. But this is designed for the V6, and I think I saw somewhere that we can do this for the Hemera hot end as well, but that's unknown and uncertain. So I'm just going to go ahead and I'll start definitely with the V6, and then I'll try using it on the Hemera tool direct drive system. Hopefully it works for both. It's telling me to use an M2.5 tab and an M3 tab, and yes and no. Yes, I understand that you want me to have threads in this, but no, 1, you didn't send me the parts to tap it with. 2, you didn't tell me to buy it ahead of time, and we're going to run into this later where they didn't tell us to buy Loctite or super glue. Why isn't that just at the beginning? It's like, hey, these are going to be all the materials you need. I collected everything that I thought I'd need. I am not going to tap anything. I'm going to let any of the bolts that I use tap themselves in. If M2.5 manages to break in this, I'm going to applaud this PLA for being strong enough to break it in 2.5, but it should just self-tap and be perfectly fine. Looks like we're going to use this kit to some extent. This is like a miracle. We are on the 5th work instruction. They finally identify a bag to use. First time. But you know what? I am happy. It's going to make it nice and simple. Next step, immediately disappointed. Simply put, what was made into 2 steps should really be 1. So they're identifying to place this grub screw into this part, and it's great and all, minus the fact that they say use super glue. And so they say apply super glue to this and put it in this part. That's step 4. Step 5 is say use a flat surface. This is an available flat surface to screw this grub screw down until flush. That, in my opinion, is a massive mistake. Because if I was going in order and I didn't check ahead in my instructions, guess what? Now I just put a grub screw into a plastic part. This is a machined plastic part too. So, but the point is, like, now I have a grub screw glued in and not set to the right height because I didn't know that it needed to be set to the right height. But we have an Allen key of the correct size and a bunch more. So that's good. We'll be able to run this in. I do appreciate they did give the design side at least some consideration, where I can slide that grub screw through to the other side through a hole that they added here. I'm gonna go get some super glue. My suggestion would have been to use a jam nut. Use a set screw that's maybe twice as long at most. Add a jam nut to it, or like hold it in place with your finger, screw it through the jam nut, get it started into here, screw it down until it's flush, lock it with the jam nut or something. I realize that getting a wrench into there is a little tight, but it's something that would be mechanical. It would add a little weight, but it's mechanical. You don't have to mess with super glue. I'm just going to dribble a little bit on with it already here. Yeah, way too much. What was that about me being messy? I don't know, I didn't hear a thing. I am as clean as the day I was born. I'm about to make a giant mess. Just ever so slightly knock it up against that flat surface. Pull this out so it doesn't get glued in. There is an obscene amount of glue in there. But now I'm afraid to pull it out, because if I fill that in where I put it into where the hex key has to go, well, 1, it's super glue, so it shouldn't ever be coming out. But it really is there just to keep it from turning backwards. But if I ever did need to reset it for whatever reason I might think of, I would lose my purchase hold. And we already saw how I applied super glue, so we get a nice little ring there. Isn't that just special? We'll let that dry. Got some thread locker. So it appears that this other side actually fits nicely around there. And that actually looks like really good as a fitment. That's beautiful. I appreciate the engineering. I don't appreciate who did instructions. So now we have some M3s by 8. We get to go back to using a different hex head. Hey, that one seems to work. So apparently it's not good enough to use thread locker on a grub screw to hold it into place. But we're going to use thread locker to hold this piece onto our faceplate. I'm going to go out on a limb and say that they've had trouble with that grub screw holding in place to the extent that they needed to use Loctite or super glue. But if they've had trouble with that grub screw coming out to the extent that they've needed super glue, it begs the question, what good's Loctite anywhere? Oh my goodness. Else, like literally anywhere else on this entire project. Well, I'll just stick you in and then I'll go fetch another bolt before I clean it up. Quick trick with thread locker, I believe I've seen this somewhere, is you don't actually want to tighten it down all the way. Thread locker is intended to dry a little bit before finishing off. It's kind of like the spray-on adhesives, where that too isn't intended for being immediately as sticky as it can. It needs some actual time to cure and start that adhesive process, or I guess growing into an adhesive process. But it needs time to grow into the adhesive process and like be semi-cured before you clench it down all the way. So I'm just gonna wick up the rest of this super glue and pray I don't need to ever take that grub screw out. It looks like it's fairly clean on the inside. I'll let those set for a bit before torquing them down. I think it sets in about 20 minutes. So I'd say maybe about 30 seconds to 5 minutes, somewhere in there, would be good for letting it sit before tightening it the rest of the way. So the countersunk screws are there intentionally to align the part, so you don't have to do any special alignment. I do suggest at least checking it. It seemed like it did move just a touch there, but going back and forth as you tighten these two. That way it generates a nice even connection and it does center as much as possible, because you know that countersunk screw should be sitting like really well in the center of those holes. And it's already a drilled and tapped hole on this part. Self-aligning, beautiful. On to the next thing. Socket cap M3 M3 6mm screws. M3 6mm. M3 6mm times 2. Cool. Then we got these two parts. I do kind of like how they have just like a little container to put the thread lock into, and then they just dip the screws into it. That part is clever. I'll be right back with the container. Here we go. Container, thread locker, Loctite, call it what you want. Probably should have shaken it first. Oh well. Too late now. We'll just go ahead and stick this down in there. It assembles like this. They told us to tap this for an M3 screw. It's a through hole for an M3 screw. That's the M2.5. It's fine. It's all fine. There's at least some good engineering here, even if the instructions are a little off. Because I mean, the fit and finish of this part off of a stock printer is just gorgeous. I don't know why they're using this machined aluminum piece to attach the heatsink for. Especially when they have the skill to design a part with this much tolerance. Alright, on to more fun things. Oh, wasn't that adorable? This is a massive aluminum block, so I'm actually going to offset it where that heating element is going to be at the lower end, and that's going to be closer to this nozzle because it's the nozzle that does all the heating. And so now you have this mechanism where it's just trying to push as much heat into this hot end as possible. So this is actually saying to assemble this first. So again, we'll just do everything we did before. They gave us heatsink compound, which is beautiful. Their steps, their instructions just told me to install the heatsink compound on this thread only. I want to spread it down to this solid area too, because I bet that touches the heatsink for cooling purposes as well. I'm sure there's thermal paste you can get a hold of for a cost that will provide high temperature solution. It'll actually self-tighten if I use this. There we go. Yeah, that's nice and snug. We have that installed. Now it looks like they want this block to come straight out pretty well as possible from there. And we can always adjust that later. Ooh, beautiful. I actually like that blue and purple together. 4 Plastifast screws. It's the screws here that have a very coarse thread and have no tip to them. Coarse thread means that it's going to grab plastic really well, create a large surface area, and so you can actually get a good amount of torque on it without stripping anything. And then also there's no tip to that whatsoever. That's highly important because that assumes that the plastic is already pre-drilled or it's molded with the hole in place. So this is not going to work as a wood screw or something where anything that doesn't have a pre-existing hole. So that's the assumption I'm going to go with. Finally get to use a Phillips. First time for everything. It looks like this is number 2 Phillips, which is like your general standard. It is saying, so this is a non-equal part where there's a edge right here and it's flat here, which means that this is specialized. I'm going to do a little deductive analysis because it doesn't show up well in these pictures. That this ledge does in fact go towards the top side because this clip part is as long as the heatsink is, and then you don't want this to actually be pushed closer to your hot end. So it's going to end up going up and away, and we're going to want our wires running in the same direction, like going to the top. So we're going to orient wires to go to this top side here. Then we're going to insert our screws, which look like they're going to be stupid long, but okay. We want the face of the fan facing out because of the points here. That's a scooping effect, and that means that unidirectional fan blade, even if the motor is reversible, the fan blade itself is not. It will push air one way better than the other. We want maximum airflow, which means that that face is going to go on the front, and all we're going for is snug because there's no tightening ability. And they might have done that out of the sake for not stripping the molded part that they have provided for us, the fan shroud, because there's so little plastic there. So I guess it kind of sort of makes sense. Just make sure you squeeze them together whenever you're fastening because it will not draw together. I'm actually using the drill because I get more control out of it. Just because now I'm not torquing around on the screwdriver, torquing on this. I don't have to be afraid of giving her some actual input. Ooh, that one was almost a through hole. there is our fan motor. As I talked about, the chamfer piece here, along with the wire, they do indicate in the instructions to face that upwards. And then there's 2 aligning pins on the inside here that face with that shroud that you want to line up in one of the holes, and it will keep it from sliding around under vibration and whatnot. It clips right in. It makes such a beautiful seat. This is kind of interesting where it'll allow it to rotate, kinda. It doesn't actually allow it to sit all the way over because it's running into that screw. Almost a great job. We could move that down a hair. If I was really concerned, I would, but I'm not. We'll see if it runs into anything. We are running this wire down and around now in what could potentially be a pinch zone if we're not cautious. So we're gonna just watch out for that from here on out. But this wire does kind of awkwardly loop down and around and back up again. Now we have our thermistor. They want the thermistor to come out on the same side as this wire, so we're probably going to end up with all of our wires coming out on one side of this. This is a through hole, so we will center our thermistor pretty well. At least stick a finger here and gently push up against that. That seems to center it pretty well. And then there's this tiny little grub screw. There is no indication of applying Loctite. I intend to anyways, being extra cautious because the thermistor is a bit of a important part, and I don't really want it coming out unless I need to change it. So here we go. Set that down in here, and just the tiniest bit of torque. As soon as that stops moving, we know that Loctite will keep it there. Never have to worry about coming out. So it's actually more secure to use the Loctite, and so you don't have to use pressure of it actually embedding itself and like the friction of the threads. You don't have to worry about the friction of the threads actually holding it in place. They say that it's not able to pass through this, but it can. Now, I might be called silly trying to do it this way, in case wiring ends up being wrong, but I like a nice clean setup. I also like how they sent stuff that they know it can't be passed through, even though they created a pass-through port. This is referenced as a high precision heater cartridge. It's rated for 24 volts. I'm going to make this part level or parallel with that bottom plate, and I'm going to do that so that it's as far away from any sort of interaction as possible. And it says use black pan head screw. The only one I can find is one of those, so I'm a little worried because there's 2 sent, and I'm going to be using one of the 2 now, and usually if there's 2 there's a pair to be used. Whatever, this is fine. Some Loctite. I just realized why they didn't use Loctite, and why you probably shouldn't either. Loctite is designed to actually degrade with high heat, roughly 300 degrees Celsius. There is that slight fact to take into consideration when using it. That design is there so that you don't have parts that are permanently engaged in something because you use Loctite. It's a intentional breakdown routine for repair purposes. So finally there's something here that's designed for repair. Now, there's a lot here designed for repair, and it's very nice. Very nice and tight. We want this really tight, not like overly tight where it's going to strip it, but just about. This will slide through here as well. Alright, so now we have all 3 pieces here. That is looking very good. They actually do have verification throughout this entire process, which is very appreciable. I wish they had that at other points with as good of images, but this is a lot easier to lay on the table and take images of than other portions. And then finally, we get to mount this. Method or orientation is you have plate on one side, this is on the top, so I think all of this goes through here, and then we're going to align it with these set of holes to our aluminum piece. So yes, that's why that's there, is for high rigidity purposes. Way overdone. If you're wanting to turn this into a high velocity or high acceleration machine, there's a number of parts that you can actually take out and make this a lot lighter, but it's not designed for that. It's designed to be like way overbuilt so that you don't have to worry about screwing anything up or having any variation. It's a very rigid machine, for better or for worse. Loctite here. Oh, that one's looking better. Let's see here. Alright. Those 2 have been dropped in. We'll just go ahead and use the Allen key. We're here already. I think it's actually a size small, but it'll get us started at least. And then alright, so that's actually kind of sexy. So as I'm tightening that, I'm going to move this, try to, and gently tighten it down as I move it more and more. That way it aligns up well and it's nicely centered, and most importantly, it's square. It ends up being square. Definitely the wrong size. Now, that looks like it's going to be a pretty lightweight machine. That's good. Here we go, we have that. I'm wondering if this isn't going to rotate yet. I'm not super fond of these wires being wrapped around like this. I really hope we get the opportunity to rotate this around and have those wires run straight up. But at the same time, I do understand that will put more mass outwards, and it doesn't look like there's enough clearance here to actually, where it wouldn't touch us. It would actually end up touching us if we rotated it this way and put our pieces in from the other side. That's that. This is probably why they were saying don't run it in the top. I'm happy finessing things, but if you're concerned about that, just go ahead and run it straight up, and it'll probably come up like right up the side right here and then into this support piece or something. Let's keep going. Okay, well apparently we're looking for 3 screws. I'll just go get 3 drywall screws. That sounds reasonable to me. That's backwards. I'm gonna put it in. I'm gonna use the original fan design for mounting this at first, just to dry fit everything. And then once I know how things are going to be oriented, I will go ahead and try the modified, or the secondary design one, especially once I know how things work and are supposed to be set up. So instructions say put fan assembly onto tool head as shown, but as shown, it doesn't show shit all. This is the best I've got. So things to note, it looks like it's using 3 holes here. Why did they didn't make this a 4-hole setup? I don't know. That would have added extra rigidity and a pretty nice setup in my opinion. But for whatever reason, they decided to go with 3 holes. There is also the usage of this, as it's going to be threaded in. It'll use this last hole here, which is good to see that it's actually being attached structurally. It'll help reduce any issues with the fan or vibrations that might occur. Alright, so now that we know how that kind of fits together, so that hole there is where it's going to attach to this block here. So now that we know how that fan's set up, let's dry fit. Man, I feel like I'm going to break that. Dry fit this fan. Well designed, I'll say that much. I like the how it grasps it from 2 sides here. Again, that fits real well. And we'll look at this bottom side here, and it looks like that's pretty centered. I'm guessing because of airflow, it will actually travel out this way a bit, and then plus that will blow it. It's not like a complete wraparound kit, but you don't have to worry about wires with this, orientation so much. I won't be able to take this and rotate it out as I was hoping I'd be able to, but that's okay. I will survive. This actually should be fine because it's blowing up this side. It shouldn't actually cool this heating block too much, where the thermistor is on the inside there, and it might cause a slight temperature variation, but I think there's going to be more issue with there possibly getting some air on the tip itself. Shouldn't have to worry about that, but it is a possibility of consideration, but that's something that's going to occur with any 3D printer hot end. That does look very beautiful design, and just look at that, all that purple and green, and the violet and green, that is just gorgeous, highlighting the black and the silver and that clear. Lots of different colors, and they all kind of mesh pretty well, I think. All right, well, let's get to assembly. Looks like these socket head screws are the screws of choice for this. They have 2 longer ones. Those are going to go through this fan shroud, and then the shorter one will be on this top corner. Is my guess, and I mean, it just kind of makes sense that way. I'll go ahead and start this. They didn't say to thread these actually. I'm sure there's going to be plenty of plastic threading with installing this. Like, it's really not mounting to much anyways. So I'm running all the way through to see how much thread I have, and that does look good. So I'm just going to back out until it's just a hair under flush, and do the same with the rest. That plastic was a hair bit tight, it cracked it. The print was, but I'm not worried about it. It's still going to have plenty of structural integrity. I don't have to worry about that. I mean, it's just holding a pretty lightweight part, and plus we're still going to have this piece to do the majority of the holding. This is mostly just to keep the fan from wobbling around too much, securing into place up top here. Now I'm just going to get these started, and then I'm going to put in the side screw. So it's not actually going to line up with the top edge of this piece right here. I guess you can probably better see it here this way. It will be essentially pulling it as far down as we can. Let's use this top corner to align it at first, and then we'll know that everything else comes into play appropriately. And you can see it doesn't really want to go in that printed hole, So that tells me that hole is a little undersized. And we're going to have issues with that throughout with all of these as well. And since that's the case, I'm going to actually send this countersunk screw in. Not draw it tight, but it'll align it and it'll make it easier to hold this as I'm applying any amount of pressure to help compensate. It's in there, but it's loose. And now we will finish up by driving these home. This is probably going to be the most tricky one. So we'll just start here since I have to use my finger to hold it in place. If any of these are liable of cracking since I didn't drill them out or tap them. So I keep backing out, trying to get a better thread in there. There's only so much you can do when it's two threaded components, so that's fine. It'll hold. And then I'll go ahead and tighten this last one down with a screwdriver. The rest of them look like they're going to be where they're going to set, so I don't really feel a need to tighten those down with a screwdriver at all. But I do want to do this one since it is the main carrier and I can put actual torque into it a little bit. So with that, they did say to run this power wire through, and it looks like you can actually wrap it down on the underside with a little bit of patience and endeavor. Looky there. That'll clean that up real nice. Maybe not real nice, but it cleans it up a little, running it all through there. Again, we still have that little guy buried in here, but he's thermistor. And then the hard part is that this is actually back thread. So what I'm going to do is grab a wrench the right size. I'm going to actually turn this the other way, and that should rotate everything without loosening it at all. And that will get me a real nice parallel setup. It'll just look pretty and be beautiful. That's what we're here for. If we can't do it, making it look pretty and beautiful, then okay, I get the wrench of many sizes. Fits on there, just barely fits in there, but that's all we need. Doesn't look like it likes that. So we're gonna actually loosen this, rotate it until pretty well set on. It's the small things that really make anything beautiful. No one ever looked at something massive and said, yes, that, because it's big, is beautiful. It's the small details that matter. No, it's not even quite 45 degrees, but it kind of gives it a unique atmosphere look to it. So I'm just going to keep it there unless I, for whatever reason, actually have to move it. Okay, we're getting there. Looks like this. They said install a grub screw there. So just take this and it goes right down and then this hole here, run it in. I think just the plastic deformation itself, as we're trying to get this to be set, will hold it into place sufficiently. Unfortunately, I don't have a hex driver that's this size. It seems like this set screw is a little small, but with enough persistence, anything will go, right? It'll either go in or it'll go to shit, but it will go. Looky there, just started. I'll need this piece as well, and these long screws, of which we were told gather parts, and I get to assume again. Okay, so what it wants me to do, and I actually think I won't do this quite yet, is this piece sets in here so, and then gets mounted to the top here, and wires get run through. The reason why I don't want to actually pursue this aside, like I'll probably dry fit it, but this is definitely going to be coming back out again. But I think what I'm going to end up doing is whatever connects to these, I'm going to actually place down in here, connectors and all. Then I'll have just, especially since I have this extra box, and then this on the top side will only have a sleeved jacket and like the wires coming into here. I think it'll be sleeved at that point, it might not, but it'll just be a set component set up here coming into the system. There's no connectors or anything else to be hairy, and that will all store nicely down inside of this little containment. But for now, I guess I will install it because why not? I'll just go ahead and pre-tap these holes. Actually, I don't even want these threaded, so what I'll do, I'll run it down here, and then it'll bottom out. And I'll strip the threads. I mean, it ended up happening at some point anyways, and it'd be nice to do it with a shorter screw. It's so long. But this will give me a very specific thread or hole size that I now don't have to worry about. But then this is going to be this final setup, and then I will just go ahead and run it into this part, and all this will be coming apart later. We'll probably actually strip all these out too. Do catty corner. 2 screws is easier to one to keep from breaking any of these plastic pieces. Ooh, looky, it's already sliding. It's good. Now we'll just take it real gently, strip the threads. Now, whenever we go to install this, it is ready to slip down over everything, and I won't have to worry about stripping the threads while I'm also going into these actual threaded holes that I want to keep the threads for, and it'll keep everything aligned just right. We're not going to assemble that, or I'm not going to assemble this until I have the wiring harness coming in. So these will actually just kind of get tucked down inside. Hopefully there's enough wire space for this to occur inside of here. And then yeah, that, my dear friends, is my tooled Bowden for the V6 Bowden. And my, is she gorgeous. Wow. I'm excited. I'm so excited. And of course, one more thing. How could I forget? Putting on the sock. Actually, I like that. That ties the blues together, I think. It gives it one more shade for your blue wire, your blue heatsink, and now your booty. You got some green, some red, violet, obviously. You got a little bit of copper in here. Just a nice palette. That is our conclusion for that. Okay, real quick, I had to make a quick edit here. I forgot to put in the Bowden receptor on the top side. It's just a little plastic piece that slides in. Nice part is that all this comes off with the matter of 2 screws, even though there's already Loctite on them. I don't think they've cured yet, so I'm just going to stick them back in and call it good. And I'm keeping the retaining clip there for the time being. Otherwise, continue on in a second.